Hi everybody, thanks for being with me here today for another installment of Oracle Live. Today we're going to be talking about bringing the power of ARM to the server side. In a quick summary, ARM is making a huge insurgence in the market. Right? ARM has obviously been doing a great job on mobile and IoT, but we're now at an inflection point in the industry where ARM is now ready and available for server-side computing. But it's more than just the actual microarchitecture. There's the infrastructure and the compute that we have to offer, and we're going to talk about what we're now launching today at OCI, our new Ampere A1 Compute instance. And we're also going to be talking a lot about the ecosystem, about how it's not enough to just have the microprocessor and the compute instances. It's also really important for the ecosystem that developers use to be available on the platform. And then lastly, we're going to be talking about some things that we're doing at Oracle to make sure that everyone has access to ARM on the server and makes it very easy for them to move their applications, their ecosystem, their workloads into ARM and also onto OCI in our cloud. So, as we just kind of talked about, there's two ways of thinking about this. You have the underlying platform, which contains the CPU and the compute instances, and then you also have the ecosystem. And so we're going to talk about those separately throughout this session here today. Let's start by going backwards in time and look at where ARM came from and where it's going. So if you go back to when ARM started, it was in a barn in the early 90s. And if you fast forward to today, you can see that ARM is now powering even some of the most powerful supercomputers available anywhere in the industry. And if we also take a look at where the industry has come from and then where we're at now, I think it's helpful to understand that so that we can understand where the industry as a whole is going. So if you go back in time a little bit and you go back to, say, the 1980s, you see we had multiple server-side microarchitectures. You had things like SPARC, you had MIPS, and you also had x86. As you move forward a few years, you had technologies like PowerPC come along. You move forward a few years more, you see things like Itanium. And then throughout the early 2000s, instead of a broadening of the industry, instead of having more microarchitectures, you actually saw a consolidation. Technologies like MIPS and Itanium became less relevant. And then as you continue on, things like SPARC and PowerPC also fell out of favor. And it really, as an industry, everything on the server side kind of ended up being x86 by default. Now, going back in time about 5 years ago from now, but suddenly the resurgence starts to happen. You see new hardware, things like GPUs, that then come with a completely different programming model, and developers have to learn how to take advantage of that. And then in addition, we're now at the point where ARM is becoming highly relevant on the server. And so one thing to ask ourselves is, where did the ecosystem go? And I find it helpful to recognize that it wasn't always that we just had a single architecture for the server-side computing. It wasn't even that long ago that we had 3, 4, even 5. And some of us may have come up as developers in a time where there was only one architecture. The vast majority of computing history, as a technology industry, we've had multiple of those architectures. And it's actually not that hard for us to make sure that our software runs across these different architectures. And so what we're going to be talking about throughout the rest of today is really deeper details on how do we make sure that we have the right platform, how do we offer the right CPUs, how do we offer the right compute infrastructure, and then what can we do here at Oracle and all of you out there, what can you do to actually increase the availability of the ecosystem? To do that, I had an earlier conversation with Renée James, the CEO of Ampere, where we talk about the new Ampere Ultra CPU and how we're bringing the power of that platform to the Oracle Cloud. Renée, it's really good to be here today with you. I remember it wasn't that long ago. Well, it's been a few months. I think we talked last September, and we were really announcing where we're going to be today, how we're making huge investments together, how we're bringing the Ampere A1 OCI Compute instance to the Oracle Cloud. I know you and your team have been working very hard, and I've seen all of the great work that you've put out and the hardware spec reviews on AnandTech and all of that. ARM has been something that we've been talking about in the industry for what feels like decades at this point.
A decade at least, for sure.
Right, but we're here now, and I've actually used this stuff, and it seems like maybe you guys have used it once or twice. It seems like it's real now. Why is it real now? Why is now the inflection point?
That's an excellent question. I think a couple of things happened simultaneously that created the right, if you will, perfect storm. We had the combination of excellent external fabrication capability in the 7 nanometer process at TSMC, which was leading edge, which gave enough performance to really build a leading edge processor. And let's face it, the cloud and OCI require leading edge to get what customers demand. And then the other thing that happened is ARM as an architecture has grown up. And over the course of the decade, it's gone from being something that people used for microcontrollers and then grew into cell phones and even into mobile devices. And now with Ampere, I think we've gotten to the point where we have enough power, enough performance, and the ecosystem is ready, meaning the software has come along to the point where literally it just works. Linux works, all containers work, all the middleware you'd expect, Java, all of that needs to just turn on and happen, or a customer like Oracle in the OCI cloud can't deploy it. And so, the combination of some external factors in addition with the environment and the ecosystem being ready, and a design company like Ampere coming along and making the most of it.
You mentioned earlier the ecosystem, and you talked about how things are at the point now where they just work. You boot up, you have the operating system, you have the development tools you would expect. Something that we're really trying to work on here at Oracle, and I know you're doing as well, is it's now that we have that foundation, how do we get everyone to make sure all of their software runs on ARM, and more importantly, the Ampere Ultra A1 instance at OCI? What advice do you give, say, a random developer on an open source project, or someone who works at a large company? What advice do you give them on how to take advantage of ARM and make sure that their software ports seamlessly?
Yeah, I think the first thing I would say to them is the Oracle A1 instance, with Ampere, the free tier is such a great offering. I couldn't be more excited about that, because we all know that experimentation and getting started with something that you can try before you buy is the way developers get excited about new platforms. In the old days, we used to have to ship 1 million platforms to people and convince them to, work on their software and get excited about the machine. Now they can try it for free at OCI, at the Oracle Cloud. And so for me, having, the Ampere instances at Oracle is a breakthrough for developers. They can get started today. The Dev Cloud is there. Everything that they need to try. It's free. They don't have to go get somebody's approval or use their credit card. So I would say, you know what? You should get on board. And by the way, a lot of developers in their personal life or in their prior life or whatever are actually ARM developers. There are more ARM developers in the ecosystem than there are other platform developers, just given the plethora of applications that are on cell phones, that gaming in the cloud, all sorts of stuff. So the ability to go and work on, enterprise class problems, if you will, in an ARM ecosystem on the cloud is kind of new news, and it's exciting.
Well, Renee, I really appreciate you being here today. I am very thankful for all of the work that you and your team have done. I'm glad for our deep and close partnership, and I'm super excited to see where we go in the future. You and the team have done outstanding work. We could not be doing this without you, and the Ampere Ultra A1 instance on OCI, I think, is the coolest thing we've done in a long time.
Well, thank you for that. We are super excited about it as well, and we're equally thankful to you, to Oracle, to the cloud team. You guys certainly put us through our paces and help us get better every generation, so thank you for that.
Let's dig into more details about the platform, the CPU itself, as well as the new OCI Compute instance that we're launching today. The Ampere Ultra A1 OCI Compute instance is incredibly powerful, and there are 3 major reasons that customers are choosing it. The first is the highly predictable performance. The second is the improved security. And the third is that it has the most outstanding price performance available anywhere, whether it's in our cloud, in OCI, or in any other cloud out there. A few more details about the server and what we're offering. So we offer it in both bare metal and virtual machines. The bare metal servers have up to 160 cores, a terabyte of memory, and 2 by 50 gigabit per second networking. Our flexible VM offering is also available on our new A1 instances, and that means that you can configure separately the number of cores and RAM that you want to make sure that you're only paying for what you use. That brings us to the question, what can you do with the Ampere A1 Compute? And the answer to that is you can do a lot. There are some workloads that are common across all businesses. These are web front ends, they are application servers, they're containerized workloads, things like encryption, decryption workloads, as well as database workloads like MySQL. And the major thing that the Ampere A1 Compute provides for those workloads is significantly improved price performance. And it's not just a little bit. When we look at benchmarks across these different types of use cases, we see an upwards of 30% price performance improvement to the next best offering that we have available. If you go into specialized workloads, so let's take, for example, video streaming, maybe video streaming conferencing software or video streaming of live sports, what you can see is that the Ampere Ultra A1 processor and the instances that we're launching today, they have higher peak performance, they have significantly improved price performance, and even more interestingly, they show significantly better performance scaling. And what that means is that you're always getting what you pay for. You're not getting variable performance based on whether you're using the minimum number of threads or the maximum number of threads. You always get the same performance that you expect all the time. Another important area that we've all been thinking about lately is autonomous driving and computer vision and how that plays into it. To hear more about that, let's listen to one of our customers, Onspecta, and how they're using the Ampere offering to do AI inferencing on OCI.
Deploying AI models in the cloud is complex. My name is Victor Jakubiuk, and I'm the CTO of Onspecta. Onspecta offers a deep learning software inference engine, DLS, that accelerates trained AI models deployed on Ultra servers on the Oracle Cloud. Onspecta and our software DLS provides the best possible acceleration software and deployment software for AI models. Common use cases include object detection, video processing, medical image applications, and recommendation engines. What excited us about this offering is that we can now offer to our customers up to 10x improved AI performance, faster time to market by reducing model deployment time from weeks to hours, and reduce cost by using more performant and less expensive hardware. I believe ARM-based servers will have a huge impact going forward in the data center and the cloud, and we're looking to be a part of history of making a huge impact on the cloud ecosystem.
Another interesting workload is mobile applications, specifically mobile games. To learn more about that, let's hear from Jenny Mobile, who's bringing their Android development platform to OCI using our Ampere instances.
So the vision for Genymotion is to be the default application for Android app developers and create an environment where Android is available anywhere in the world at any time. What that lets the developer of an Android app do is high volume testing, high volume QA, because we emulate the entire device. And that performance translates directly into the amount of time it takes for them to execute their tests or quality assurance tests on the Oracle Cloud. We would see 10 to 100 times better performance, up to 10 times more occupancy, which means I can put more virtual devices on the same similar sized server. That saves them time or gives them the ability to run more tests, get more code coverage, test more of the corners of their applications, find more bugs faster. Our customers tell us that this saves them not minutes, but multiple hours in terms of test time.
Another area that's really important these days is high-performance computing. Not everyone knows that ARM processors, specifically the Ampere Ultra processor, is playing a big role in that. The University of Bristol is doing computational fluid dynamic workloads on top of the Ampere instances we've just launched. Let's hear more from them about that.
The University of Bristol, it's in the southwest of the UK. It's one of the top 10 universities in the UK. My name's Simon McIntosh-Smith. I'm a professor of high performance computing at the University of Bristol. We are on the cutting edge of technologies that might be used for doing things like computational fluid dynamics, designing new jet engines, new aircraft, things like that. Pharmaceutical companies might use for doing drug discovery and drug development. We were really excited to get early access to some of the new instances of the Ampere Ultras. We've basically been seeing performance that's competitive with the very best of any other technology we've tried. In terms of performance per dollar, in terms of the cost, it gets even more compelling. Our experience of trying out these new instances was actually really straightforward. Everything just worked, and then everything just ran really fast.
We've talked a lot about the platform itself, and now it's time to talk about what we're doing in the ecosystem. Well, the first thing to recognize is that the ecosystem is actually already very rich. There are a ton of offerings available today. As Renée said in our talk earlier, that ARM already just works, Ampere just works. And you can see from this slide the huge variety of offerings already available. And I want to take a minute, though, to talk about what we at Oracle have been doing specifically. So if you look at things like Oracle Linux, MySQL, Java, and Graal, we've been investing very heavily in these technology platforms, in some cases for many years, to make sure that they run incredibly well on top of ARM, and more specifically, the Ampere Ultra processor. But we didn't stop with just the technology that we have at Oracle. We've been working in the industry with partners like GitHub and GitLab and Jenkins to make sure that they have the super integrated and high performance CI/CD pipelines needed for developers to bring their workloads to our cloud. In addition to that, we've been working with the Continuous Delivery Foundation to make sure that ARM and OCI are a first-class citizen and are very easy for all developers to use. And another critical partnership that we've been working on is with ARM Limited itself. And so to understand more about that, let's hear from Chris and the great work that they've been doing.
ARM is the leading provider of processor IP and has been providing that IP for over 30 years. Over 180 billion devices have been shipped with ARM's CPU IP. ARM is excited to partner with Oracle and Ampere to announce the general availability of ARM compute shapes on the Oracle Cloud infrastructure. These latest Ampere processors are based on ARM Neoverse technology, demonstrating leading performance, breakthrough power efficiency, and significant cost savings compared to traditional architectures. It is exciting news for enterprise customers running complex and demanding scale-out workloads. Customers running applications on ARM-based processors also benefit from its secure architecture, as these processors are not exposed to the security vulnerabilities that can exist on other CPUs. We believe that ARM is going to be at the forefront of much of the transformation that's going to happen, whether that be in the future connected world or whether that be in the future of cloud computing.
In addition to those investments, we're also doing more to make sure that everyone has access to ARM and it's easy to use. So firstly, we created the ARM developer portal on OCI. And on that place, it's a one-stop shop that gives developers access to all of the tools, documentation, and resources they need to have a really great experience developing ARM applications on OCI. Not everyone is familiar with the OCI free tier and our always free services, but for years now, we've given everyone who wants one an account, as well as a set of more than 20 services that they can use for free forever. And we're adding our new Ampere A1 instances to that. So anyone who has a free tier account, who already has it or signs up for a new one now or in the future, gets access to 4 cores of ARM compute, as well as 24 gigabytes of memory. If you're, say, an individual developer or a hobbyist programmer, this is great for you. You use the free tier, you get the $300 in free credits, you get the always free services, life is good. But let's say that you're maybe an open source developer, or you work at a research university, or you just need more than you can get with the free tier to develop your application that contributes to the ARM ecosystem. For that, we've created the ARM Accelerator program. And what that does is it gives you access to free credits to use towards developing the ARM ecosystem. We have a great website. You show up, you sign in, tell us about your project, and then we'll get back to you with free credits on enabling that use case. And then, as a great example of that, the University of Jena is doing seismic modeling on top of OCI, and they're taking advantage of our ARM Accelerator program. Let's hear more from them.
The University of Vienna is over 450 years old. And, what we are looking here in Vienna at is large-scale computational sciences and data analytics. What we are trying to do is simulate ground motion and is a hazard to society. Our workloads in this regard are tightly coupled. That means all of them have to work at the same time at the same problem. So we need very reliable and very well-connected computers. What are the benefits we see from the A1 shape? I think it's largely in performance compared to what we have on other in one architectures. It's important to us to have a choice of different architectures. Specifically also important that we get access to the very recent architecture very early in the process. We get access and we can teach our students in the most recent computer architectures, which also makes this A1 instances exciting.
At the beginning of this session, we talked about the great market momentum that ARM is having on server-side computing. We've covered the work and the massive investment that we've been doing at Oracle to bring the power of the Ampere Ultra processor to everyone. And we've also talked about what we're doing in the ecosystem, whether it be the ARM developer portal or working with our partners to make sure that everyone has access to what they need to make sure that ARM is really first class. So we've jump-started the ecosystem, but now it's your turn to help. And to do that, it's actually not that hard. All we need you to do is to start your next hobbyist project on top of ARM A1 Compute. We need you to start make sure that your open source project runs on the Ampere A1 instances. We need to make sure that whatever you can think of that will contribute to the ARM ecosystem, please, we're here to help, right? Come use what we're giving away freely available, help contribute to the ecosystem, and make ARM really the place that it needs to be as an industry for us to take advantage of the significant performance and technological and efficiency improvements that are coming in the coming years. With that, what I do want to say is I want to say thank you to everyone. Thank you to our customers and all of the great work that they're doing. Thank you to our partners, without which none of this would be possible. And also thank you to all of the viewers. I know it takes, everyone's super busy. I really appreciate the time and energy that you've spent here today listening to me. And obviously the kind of in advance, thank you for the work that you're going to do as you use this ecosystem and use our instances and make this a great place to develop ARM applications.